MCP servers, or the Model Context Protocol servers, are basically a way to connect your AI agent to external tools and allow them to basically perform actions on your behalf on that service. And the first time I heard about being able to hack these tools, I thought it was going to be really boring because it would involve me having to hack these AI companies like Anthropic, OpenAI, and like Gemini or whatever, because they were really the only ones who were actually implementing these MCP tools, because why would any other company have a need for this? They don't produce chatbots, right? But then seemingly over just a few months, it seems like every company now from the Fortune 500 pool just wants to really be an AI company now. Just no matter what company you go to, there's just an AI chatbot, and for some reason these companies feel the need that these AI chatbots should now have MCP tool access on behalf of the user. And this has made the attack vector for these tools significantly larger than it was before, where it was more limited to these AI companies. Now it's like any company in the world has them anymore. And it's a really good scope. It's really good for escalating prompt injections. It's really good for even getting 1 or 0 click attacks against victims as well. And I'm going to talk to you a little bit about that today. I'm going to explain how these MCP tools work, how the authorization for these tools most of the time works, most of the time through OAuth. And then I'm also going to show you a live example where I basically just asked an AI tool to build me an MCP like application, and I'm going to try and hack it. So that's what we're going to do. And we're going to jump straight in now. So what is an MCP server? To give you the long story short, MCP server is basically usually just a wrapper around some API that some external service has basically implemented into it. And this is usually the way it works. So you have these two applications and then a user in between them. So the user is normally on the AI application when they want to start the MCP process. So they go to the AI application, they configure their MCP. The way to do that is they just type into a box the MCP server they want, usually some kind of URL, or maybe there's already an app inside of the AI application that basically controls how this all works. And then the AI application is going to be able to make requests, MCP requests, over just normal HTTPS, and they're going to be JSON RPC requests. They look a little bit something like this, and we're going to get into this a little bit later. But basically the MCP client, so the AI application, is going to be making post requests to the MCP server, and then the MCP server is obviously responding to those requests accordingly. So the thing that first of all happens is the server makes like an initialization request, like a handshake request. But you could think of it a little bit like WebSockets, where it's like an initial like handshake request. So the AI application is kind of like checking if the service is actually, able to do MCP and whether it's actually working. So the AI application sends that request to the external service. We'll say this is like box MCP service or something. Maybe we'll just assume this is like mcp.box.com or whatever. So this is sending this to box, we'll say. Then usually what happens is the external service will say, there are tools available, but not for you, buddy. So you got to authenticate first. Because normally these external services are gated behind some kind of login or whatever. So we can't just have the MCP service accessing whatever it wants to. So it usually gives us 401 request back. And inside that 401 request, it usually includes an OAuth link. So this is normally going to be done through OAuth, which is kind of the protocol standard. Sometimes with these external services, you can also configure them to use API keys. Actually, a lot of the times you can, but it's actually not really used that much because these API keys are not as secure as just using OAuth. So the server will send a 401 back, and it'll be like, okay, use these OAuth servers to basically authenticate yourself. And what will happen is the AI application will redirect the user to that OAuth endpoint, as this is normal OAuth flow. It'll get redirected. There will be like, a big URL with also like a redirect URL in it. And this is going to be something that's inside the external service. It's going to be a URL on the external service. So the user is going to authenticate to the external service. They're going to, put in their password and credentials or whatever. And then the external service, as normal, is going to pass back an OAuth code back. So this is not an access token. This is not something that the user can use to actually access their data. This is just something that can be exchanged for a token later. And the user will pass that code back to the application, the way this works basically is that the external service will then redirect the user back to the application from the redirect URL. And then the AI application will exchange the code with their secret that they coded inside this OAuth application for the access token. And this access token is actually what will allow the AI application to make these requests to the external service using the standard MCP protocol clients. So it'll be able to like list the tools, and it'll be able to call stuff on behalf of the user. So once you've authenticated the app, they will be able to do anything that you've basically allowed in that checkbox. I mentioned before, this is kind of what the initialization request looks like. So this is checking basically if the application is able to use MCP. So this is what's sent by the server. And then usually there's like a 401 response. And then after the server authenticates, it puts like the access token in the bearer token. It also has like a refresh token and all. And then it's able to basically do these MCP requests after. Then just to give you one more example, it's going to be like this one. This is what the server sends to list tools, basically asking the MCP server, what do you have available? And this normally gets like piped into the AI's context or whatever. So this is basically provided to the AI later. And there's a lot more of these basically. There's like resources and stuff. There's like, what else? Resources for like markdown files. I think for calling a tool, it's like tool/call, and then you put in like the parameters here. There's like a more comprehensive list of this online, so I'm not going to go through all this. You can just go ask Claude or whatever. You don't need me for that. But I hope you understand that. So that's, if you understand the flow of basically how this authentication works, then you will understand a lot more later on what the vulnerabilities of this will actually be. When we move to the client and we add different users in, how do we gate this MCP server from other users? How do we prevent prompt injection? And how do we bypass some of the methods that developers have put in to prevent prompt injections as well? So I've asked the AI to just literally code an application for me that uses MCP. I haven't asked it to code any vulnerabilities in. I've used Opus 4.7, so we're going to have a look. The AI, by the way, is Gemini 3.1 Flash Lite, which is actually, it's a pretty good model, but it's kind of cheap, so it's not going to be that great, obviously. But we're going to have a look at it. And unfortunately, I can't make this lab public because I can't afford to run an AI chatbot with MCP. I'm unfortunately not a Fortune 50 company. So I'm going to hopefully include the source code for this, like there's like a Docker container for this in the description. But you have to put in like an API key yourself for the AI, just off OpenRouter or whatever. Or I think you can actually use like a free model or something as well. So maybe you can do that. But anyway, we're going to hop into the labs now. This is the app that I've asked the AI to create. It was just this like LLM Kanban style thing. I had to get it to debug it a little bit though. It was a little bit broken, so I had to get it to debug it. I actually got it to test it by itself as well, using my accounts and stuff. So it is actually pretty nice. So we'll see what kind of security vulnerability it's coded in here. So we'll have a look at some of the prompt injections that we can do and some of the other things that we can maybe manipulate. So I think I have one of these accounts authorized, but I'll just also show you how the authentication flow normally what looks like as well. So we'll have a look here and we'll go and create like testy board or something, and we'll make it public just so I can put the other user in. So I've increasingly seen that a lot of these AI tools now, the way they kind of work is that there's often a collaborative setting to that now. So instead of usually there was like one user prompting one AI, there's actually a lot of the times now kind of a collaboration where multiple users can prompt the same AI in the same session, which I found very interesting because there's normally kind of like a barrier with prompt injection where normally you can't deliver prompts to users unless the AI is kind of taking in some kind of information. But if you're sharing the same chat, I find that it's actually a lot easier to prompt inject because you literally don't have to. You can just hide some kind of message in one of the other messages that you send to the AI, and then the AI will hopefully like execute it on behalf of the user. Especially with MCP tools, where I'm gonna let me just open this board as well on this user. You can see one of these users has the MCP server connected. With these MCP servers, you can see one user has the MCP server connected, one of the users does not. So the attack surface is kind of what I'm thinking is perhaps there's a way to prompt inject as one of the users to hijack that MCP server. Another thing I often see is when there's some kind of sandbox happening. So if you think about sandboxes, they're often some kind of containers that are running on like a separate environment, but they also kind of want to have the AI be able to use MCP. But they want to have coding agents that are able to freely modify any files. But if they have the coding agent do that, they're basically given RCE to the person who has the coding agent, right? So if you run something like Claude with dangerously skip permissions and you allow a user to prompt them, then you're given the person like RC, right? If you use Claude Code, because they can just tell Claude to like write files or whatever. But the way they do that is they kind of just sandbox it into like a virtual machine or whatever, and they have Claude not be able to get out of that virtual machine. But if they still want to have MCP, then they still have to have some kind of way for Claude to have the access tokens for those applications. And if they want to have both worlds, you're going to have to compromise somewhere. You're going to have to put the access tokens inside the container. And that's going to lead to those vulnerabilities where the access tokens are being mishandled improperly. Now, I didn't code that here because it's way too complicated, but I just want you to be aware of the different scenarios where your MCP server is getting taken. So where are the access tokens being stored? How is it bound? Is it bound by user, by organization? If it's bound by organization, then are other people restricted from calling certain MCP tools? Like how is this working, right? So you first of all need to get an understanding of what the MCP server authorization context is in. In our case, it's per user, but users can talk on the same chat and access the same kind of information. That's like a very good prompt injection vector. If it's per user and the AI is accessing the same information, then we have a great prompt injection vector, especially if the AI is not asking for permission to run the tools, which is even better. So we're going to start a new chat, and we're just going to see what's the story here. We're going to text it like hello. And so we see we have no authorized MCP servers, and we're just going to ask like, what tools do you have available? So I'm going to ask what tools there's available. Yeah, these probably different tools. These are just injected into the context of the AI. So in terms of the system prompt or whatever, these are included. But we're going to ask like, do you have any MCP servers? We'll ask here. And it doesn't appear like there is. Sometimes there are default MCP servers included, which is fantastic. If there's a phenomenal MCP server, we need to see how that's being authenticated, what things we can call or whatever, and like how it's being stored per user. But there are no default MCP servers. It's actually really good if you have like a default MCP server where you can read files, because if that's the case, then you can prompt inject anyone and read their files, right? You don't even have to have that step of adding an MCP server, which is even better. Okay, going as a normal user, we can hook up to the same session as the other user, and we can just ask here, what about now? Do you have MCP? We ask it here, and now it seems that it does actually have an MCP server. So this is being basically done per user, so the context is changing per user, as we can see. So now we understand how that works, and maybe I'll show you just how the authentication works. I'll actually turn on Kaido for this so you can see. Maybe I'll do it with the others actually. Okay, I'll move Kaido over here. That's the main menu. Just full screen it, and will I do on this? Okay, I'll do on this user. So we'll just delete the MCP server. So usually the way this works is that person will come in here and just add the MCP server here. They'll click add, and then you'll see the server has registered the MCP server, but now we need to authenticate the MCP server. So you can see this is like usually like some kind of post request here. So if we go here, you can see we've included this URL. Now, the one thing that you can actually test for even is what this URL is actually allowed. So usually MCP's SDKs, this is fairly limited our attack surface here, because these standard SDKs tend to be a bit more secure, especially for MCP. But maybe there's other protocols available. Who knows? We'll have a look. I mean, Cloud coded this application. No, it does seem like that was available. Okay, we'll have a test of that later. It probably won't work, but we'll see. Okay, so we have two now. This is the actual one here. I'll show you how the authorization works. So press authorize, and you see this menu right here pops up, and this is like the standard OAuth thing where you can see there's an OAuth here. There's a client ID registered, and now this code challenge is actually mandatory. So there's a code challenge, and there's a redirect URL that's going back to the application. So now we just approve it, and it's going to redirect us back basically. Okay, authorized. If we go here, come back, you can see there's a GET request being sent right here with the code and a state parameter. So you can see right here that there's OAuth, not the standard OAuth stuff you can do here. You can probably see if the state parameter is validated. Because this is AI, it's probably not, but we're just going to leave it for now. And you can see we have these two figured out here. Maybe we'll try and authorize this file. Okay, decided to not be able to fetch it. Let's see what happened. Okay, that's probably not gonna, well, it's usually not node fetch actually, so maybe we'll be able to access something in localhost or whatever. So I guess you can have a look for those kind of MCP vulnerabilities as well. This is using node fetch, that's why the file failed, is because node doesn't allow these kind of protocols, but you could try different protocols as well. And those are the server-side vulnerabilities there. But we're gonna have more of a look at the prompt injection side today. So anyway, we have this authorized, and you can see now that our AI will be able to use it. So what kind of prompt injection risks exist here? The main one is, where is the AI drawing information from? Well, the actual board itself. So if you can embed some kind of prompt injection here, we'll be able to deliver a payload to a victim. The other kind of thing is here, which is messages. So messages are a prompt injection vector. Now you have to be careful with this because we don't want to just make it seem as if, we're just like telling the AI to do something. Like obviously someone's not going to be stupid enough to like see a message like on the next message do something on my MCP server. They're probably going to be sus of that. So we kind of need to wait to smuggle in our payloads a little bit more creatively than just doing that. So there's a few good ways to do that. One of them is attachments. Sometimes the way these AI models do attachments is they basically take the attachment and they just put it into the AI's context, and they do that for every single attachment inside the chat basically. Now the issue with that is that if I upload an attachment to like up here, then so someone's not going to download every single attachment to have a look at that. So I would consider that a valid prompt injection vector if they just take the attachment and go like into the context basically. Another thing, and this is really one of my favorite ways, is with this thing, this ASCII smuggling. See, I've been testing this a little before. I've tested basically how this model reacted to these invisible ASCII characters, and basically on a lot of the kind of stupider models, when they read invisible ASCII characters, they tend to treat it as real text. So on this Gemini model, it's kind of stupid. So it's basically going to evaluate this as real text. So I'm just going to basically give it a prompt to create a task on the MCP server, but only to do it on my next message. So hopefully what happens is that as the user that doesn't have access to the MCP server, I'm going to be able to plant this prompt injection somewhere. The other user is going to come around, they're going to send a message, and we're going to be able to hijack their MCP server. And the MCP server is connected to Linear, which is just some random code-based app that I figured out existed. And it's going to hopefully create some task here. So let's give it a try. We'll create a new session and we'll say something like, hello. We'll just make it like subtle. And then actually, first of all, we'll say hello. Then we'll say like, how are you? Just something like inconspicuous. And then we'll come here to this ASCII one. We'll encode our characters and then we'll just paste them in here. So hopefully the AI understands that worked. Hopefully that actually did work and I don't look like an idiot. So we're going to come here, reset it. We're going to come here. I'm going to say create a task called write code 1. So we're just going to, this is like the user with the MCP server now. And we're going to just send that message in. And we're going to see if the AI actually, creates the task on the MCP server as well. And it did. Look at this. See, this task was just created now and we never knew. So so we just smuggled in an MCP payload. You can't even see, you can't even select it. So the only way you would be able to see this is if you went into Kaido, potentially. You went into here and at some point you would see that there's like a task here or whatever. You can barely see it, but it is there. There is like bytes here that the AI is reading, but we cannot read. So basically, that's one of the ways we can smuggle in a prompt injection. The second way is to obviously smuggle in it in here. So by creating a new task, and the way I like to do it is to use new line characters to kind of escape some of the text. So first of all, I would go, like, as the attacker or whatever, I'd go here and I would set a new chat and say, like, how are you reading tasks from the board? I would ask it, like, how are you reading tasks from the board, right? Calling get board tool. So potentially it calls this get board tool, that fetches the task from the board, and then we can read it in the context, right? And then there's one task on the board. So it read that, and you can see that there's the name of the board, and it seems to be delimited by these two dot characters. So that's important to me. It seems like these two dot characters are going to basically allow me to do the prompt injection. So what I will do here is we need to write it in a way that the AI kind of expects it, right? So we need to write these two dot characters here, and we need to say like a task. So we'll say something like inconspicuous, like write code 2 or whatever. I wanted to, oh, that's not what I wanted. I was hoping to put a new line character in, if that's possible. Let's see. If it's not, then we'll just have to tank it. So we'll put write code inside of this, like this. We'll like escape the task basically. We'll put like a new line character. Actually, maybe not like this. We'll see if we can modify that in Kaido to put the new line character in. But then we'll encode our payload again, paste it in here, and save the task, right? We'll just delete the normal task as well. So hopefully if the person, the kind of admin user goes to try and create something on the board, the AI will read this task, the prompt will get loaded into its context, and we will achieve the prompt injection. So let's have a look at this. So now we're going to switch to the admin user again. I'm going to create a new chat. I'm going to say, I'm going to delete that original task actually, just so it doesn't get confused. Where is it? Here. Okay, we'll just delete this, and then hopefully it's going to create it again. So then we'll come here and we'll say read the board and create a new task called write code 2 in the, let me just refresh this. Did it actually create that task? Yeah, okay, there you go. Yeah, we'll just do this. Say read the board and create a new task called write code 2 inside to do. Hopefully we can get some kind of injection. If not, we'll have to go back and modify this. We'll see. Probably didn't work that easy this time. Yeah, that's probably to be expected, but we can try and manipulate this a little bit. So I'll go into Kaido and I'll show you some more tricks then. Let's have a look at where this actual task was created then. Let's have a look at where we created this. Yeah, it's right here then. Okay, let's put that into the replay tab. Column ID is fine. I'm going to get rid of the prompt injection payload. So basically the AI is going to see a task like this, and we just kind of want to see if we can basically inject our own characters in here. So the way I would do it is escape first of all, put some new line payloads in here, and then maybe create a new task like, I don't know, something testy task. And then I would probably, maybe not actually, that's what might confuse it a bit more. I might put this in here just to close the original tag in here. And then I'll put in some instructions in here. So maybe it won't think that this is a task. This might not be a viable vector. We'll have a look at this. And I'm going to copy this again, encode and copy. And then I'm going to hop into Kaido and I'm going to say, paste it in here. I'm going to send this over. It seems like it's created it, hopefully anyway. And we'll try it again. Say, hello, read the board and create a new task called test in progress. Go. Hopefully it'll do it interestingly this time. Okay, it seems like it's created something. Has it created the task though? Okay, it doesn't seem like it's going to prompt inject from here. But we did find one other way to do it. We'd probably have to spend more time building up that other payload here. You can see that the characters are embedded in there. The AI isn't exactly reading them the way we want it to read. So we might have to refine that payload. But these are the main ways that I would think about getting prompt injection inside of this LLM. And there's probably many more things you can do, like exploiting the MCP servers, outbound connections, so looking at actually the implementation for OAuth, which is a whole other can that I'm not going to open today, adding the MCP server, SSRF with the URLs, with images or whatever inside the applications, and then the actual prompt injection vectors themselves. And then the final thing, which I touched on, is the sandboxes, which is very important because sandboxes are like everywhere now with containers. This provider called Modal does them a lot, these LLM containers, and we want to have a look at them, see how MCP is being implemented there, what kind of access tokens are being used, how are they getting the access token to the container, how is the access token scoped, and to who is this accessible, to who is this sandbox actually accessible. And these are the questions that you need to answer when you're attacking an MCP application and you're hunting. So you can see the attack surface is ginormous for this. Really, it's really huge. It sounds easy to implement this, but it's not. It's actually very hard. You can see that I've asked the AI to implement this and it's already gotten it wrong. So the chance that this is going to be wrong on a lot of companies is big. And I think this is worth looking into, and I do hope that this kind of helped you understand some of the concepts of attacking MCP as well. I hope you enjoyed this video covering MCP servers and some of the vulnerabilities that are hidden inside of them. It is a little bit complicated as well with this MCP stuff. There's a lot of terminology and protocols, but I hope that you at least have grasped how they authorize information, how users can add MCP servers, and how this kind of dynamic works, where the external service is actually trusting the AI application with the credentials to the external services. So these prompt injections are basically amplified every time you're able to get them. And any traditional web security vulnerabilities is also going to be really great here as well. So this is really what's worth looking for. And I'm trying to avoid making videos that are just basic, explanation advice that you can just get off Claude, because that's obviously not the point of watching a YouTube video anymore. Because if you wanted fast information, you could just ask AI about it. But I want to give you some tips from kind of things that I've seen, things that you shouldn't look for, things that you should focus on, and things that companies will actually pay you for. Because Claude will tell you all the vulnerabilities, but it won't tell you the ones that are actually worthwhile, the ones that are actually common, and the ones that actually pay. So this is the interesting things that I really care about. And I also hope to give you a good visualization of how these things work, and by explaining them in a way that's approachable to you. So anyway, if you did enjoy the video, then please do leave a like and subscribe to the channel for more bug bounty content recommended to you in the future to give you that edge over the competition, so you find the bugs just that little bit faster and end up not duping on on the target. So yeah, that's it for me. Thanks for watching and happy hunting.